Greetings to all, and thank you for taking out time to watch our video where me and my team members of CPG 20 from Thapar University will be demonstrating our project, and that is an autonomous human following robot. In the past few years, the field of robotics has grown exponentially. Such innovations were only a dream, but due to rapid advancement and development in technology, it has become a reality. An autonomous guided vehicle, specifically a human following robot, have become an important subset in this rapidly advancing field of robotics. And it also has gained a lot of attraction and attention from researchers. These robots have a wide range of applications in diverse domains, such as in manufacturing, warehouses, in healthcare, in entertainment industry, and for social interactions also. So we have developed a four-wheel robot that is based on computer vision, where the robot visualizes the surrounding by the frames fed into it through the camera, and then with the help of sensor fusion and navigation model, our robot moves in the real world, avoiding any obstacles that come on its way.
In the beginning, we are importing the necessary packages, which is OpenCV, NumPy, Time, and Util. Util is basically our navigation module, which is used to give commands to Raspberry Pi, which in turn will control the motors and control where the buggy will go. Here is the Util, our navigation module. Here we are loading our object detection model, which is YOLO V3 in this case. YOLO V3 is basically a pre-trained object detection model which can detect up to 80 classes of objects, and it gives high performance and accuracy out of the box. Here we are reading the label of each class from the file called coco.names. In this line we are loading our test video, and since our project will work in real time, so 0 is written here, and it means that the feed is coming from the camera. In this part we have started reading the feed, and the following code will run as long as the feed is coming. In this part we are constructing a blob, which is basically a group of connected pixels which will form the bounding box from the input stream, and then we will perform a forward pass to the YOLO object detector, giving us our bounding boxes and associated probabilities. This line gives us our output layer. Here we are initializing our list of detected bounding boxes, their confidences and class IDs respectively. Here we are looping over each of the layer outputs. Here we are looping over each of the individual detections. Here we are extracting the class ID and confidence score of our current object detection. Here we are filtering out the weak predictions, and we will only consider predictions where the probability of detection is more than 0.5. Here we are defining the coordinates of the bounding boxes which will be created when a person is detected.
Hello, my name is Rohan Gaur. And now we have seen how the codes of this project looks like, and now we'll be looking at what's the hardware structure of the project, and also we'll see the required tools that are deployed in this model. So first of all, we shall be using a Raspberry Pi module, which is powered by a battery of 5 volts and is connected to motor driver and all the sensors. Motor driver is powered by a 18-volt battery. This 18-volt battery is connected in series. Means basically two 9 volts battery are connected in series. Secondly, this motor driver is when in the part of two. There's a left section that contains two wheels, and there's a right section that contains the two wheels. And the motor driver controls the whole part in this format. Also, we have an ultrasonic sensor and a Pi camera, which is connected to the Raspberry Pi module. This camera captures a frame and sends it to the Raspberry Pi for processing. PiCam can use an footage of 4K with 60 FPS, which helps the model to perform its processing better. Raspberry Pi module, we have connected the Raspberry Pi camera to the pin 15. Pin 15 is an optimal choice for Raspberry Pi because Raspberry Pi cameras only run in two-lane MIPI. Whether it's a camera interface or the camera driver, all of them are two-lane based. Also, we have connected the ultrasonic sensor. This ultrasonic sensor has been connected in the form that the VCC is connected to the pin 2, the ground is connected to the pin 6, the trigger is connected to pin 12, and the echo is connected to a resistor on the end of to the next to the resistor we have connected the other end of the resistor we have connected it to pin 18, and through another resistor we have connected it to pin 6.
This is a sample video that we have run on our software model where we can see our model can detect a woman and draws a bounding box around it, and there is a yellow dot which tells us the center of this bounding box. And we can also see that there are green lines and a green box at the center of the frame. And whenever a certain portion of the white bounding box goes out of these green lines, a move command is given to the robot in the direction so that the person comes at the center. So this is how our robot will work, and it will follow the person around. We would like to thank our teachers and Thapar University for providing us with such an opportunity where we could apply our learnings of the curriculum and where we also learn new technologies and skills while applying it to develop some futuristic solutions.